Now that we've got the notes down, let's try some of these problems out, see if we can practice using what we just learned. So I am going to open up this. So this is the Ohm's Law worksheet that you should be working on now. This is the first one I want you guys working on today. So after you guys finish your notes, hop onto this worksheet. This is what we should be working on. I'm going to write at the top here the table that I kind of wrote down in our notes just to remind ourselves. So voltage is V measured in volts. Current is I measured in amps. And resistance is R measured in ohms, which is an upside down horseshoe. So this is what we're looking for when we go ahead and do these problems, right? The three equations that we could possibly use are up at the top here. Those are the Ohm's Law equation, right? Written three different ways, giving us the relationship between voltage, current, and resistance. So what we want to do is look through these problems, check out the numbers, right? See what the units are, see what they're given, and see what we have to find out. So for example, right, first problem here, what is the current? So there's our question. What is the current in a 160 V, which is volts circuit, if the resistance is 2 ohms, upside down horseshoe? All right. So based on what they've given us, right, 160 V, that's volts, which means they gave us a voltage. So I'm going to write 160 right up here because I know the voltage is 160. Resistance is 2 ohms, right? Upside down horseshoe is ohms, which is resistance. So R is 2. And then my question, it tells me right at the beginning, right? Maybe I underline that with a different color. What is the current, right? That's what I'm looking for. I'm looking for I, which is current. So I've got two numbers, one's missing. I'm going to use the equation up here, right? The different choices for Ohm's Law. I'm going to use the equation that solves for what I'm missing, right? And for the first problem, I equals V over R is the equation that solves for current. So that's the one I'm going to use. So I'm going to go ahead and do I is equal to V divided by R. I know V is 160. I know R is 2. So I equals 160 divided by 2, and 160 divided by 2 is 80. And now 80 is just a number. We're calculating a current, which is I, which is measured in amps. So I should put an A next to that and circle my answer. Current is equal to 80 amps. All right, so that's all we have to do for these. Read the question, see what they're asking us to find, plug in the numbers that we know, and then use the equation that solves for what we're missing. All right, so second one. I find my question first. Again, the question is, what is the current? So I know I'm looking for I again. I can actually put that in now. They give me 160 volts, same as the last problem, and this time 20 ohms. So volts was 160 again, 20 ohms, and I can do the calculation. All right, same equation because I'm looking for I again. I equals V divided by R, and I equals 160 divided by 20, and 160 divided by 20 should give us 8. And again, we found a current. Current is measured in amps, so I'll throw an A at the end there. And there is my current, 8 amps. All right, so I'm just going to keep going through these so that you have the answers if you need them. If you're good with that, right, you kind of understand what's supposed to be going on. You don't need to watch the rest of the video. You can just go ahead and do the rest of the calculations, but I'll solve them here in case you need this as a reference. So I'm just going to keep going. What is the current? Same question. 160 volts again. Resistance of 10 this time. So voltage is 160. Resistance is 10. Ohms. Current is what we're looking for again. And we get the same equation. I equals V divided by R. I equals 160 divided by 10. And 160 divided by 10 should give us 16 amps, I believe, if I did my math right there. 16 amps. And last but not least for this little section, then we'll get a extra question here. What is current? 160 volt circuit. So there's my voltage, resistance of 5. So 160 and 5. And we solve again for I. I equals V over R. I equals 160 divided by 5. And 160 divided by 5 is 32. I'm going to guess 32 and not get a calculator and check and just believe that I'm right. So current is 32. All right, there's our answer for number 4. So question 5 is asking about how current changes when resistance changes, because you'll notice 160, 160, 160, 160. We kept the same voltage in all of these. So what happens to the current as we change resistances? If the voltage stays the same, how does the current change when we go from 2 ohms to 20 ohms to 10 ohms to 5 ohms? So we should notice a pattern here, especially as we go from 20 to 10 to 5, right? What's happening to the current as we go from 20 ohms of resistance to 10 ohm resistance to 5 ohms of resistance? Well, current goes from 8 to 16 to 32, right? It doubles, it doubles. So based on questions 2, 3, and 4, what happens to the current as the resistance decreases? Well, as the current resistance decreased, right? It went from 20 to 10 to 5. Current increased. It went from 8 to 16 to 32. So as resistance decreased, I'll write this down as current increased, which should make sense because resistance is what stops current. So if we have less of it, we should get more current. And the opposite of that should be true too, right? If resistance increases, so as resistance current should decrease. Because we get less current. All right, more resistance means less current, less resistance means more current. So resistance decreases, current increases. Resistance increases, current decreases. So there's a little summation of what we just learned in the first part there. All right, so all those questions were about current. We were keeping voltage the same while changing resistance. All right, so let's try 6 through 8. We get our new question here. What voltage is required? So now I'm looking for voltage. My question is V, 6 amps. Amps is A is current. All right, so that's our current, right? You can see all our answers here were amps because we were looking for current. So 6A is going to be a current. And 5 ohms, we know ohms is resistance now. So this is 5 ohms. So we want our equation that solves for V. If we go back up to the top, equation that solves for V is right here. V is equal to I times R. So voltage equals current times resistance. So we can come down here. V equals I times R. And we know the voltage, or sorry, we don't know the voltage. We know the current and we know the resistance. It's 6 and 5. So V equals 6 times 5, and 6 times 5 will give us 30. And because we solved for a voltage, we'll throw a V at the end to let us know that it's volts. And there's our answer, right? Real simple, right? Ohm's law is nothing crazy. Excuse me. On to the next one. Again, same question. What voltage? So I'm looking for V again. Excuse me. 6 amps, there's my current. 10 ohms, there's my resistance. So 6 and 10. And because we're looking for voltage, it's the same equation we used before, I times R. So we'll get 6 times 10, and 6 times 10 is 60 volts. There we go. Next one, voltage again. Same current, 6 amps. This time we've got a resistance of 20 ohms. So 6 amps, 20 ohms. And we're still looking for voltage, so same equation, V is equal to I times R. 6 times 20. And 6 times 20 is 120 volts. Is our voltage. All right. So 3 questions about voltage. Current stays the same, resistance is increasing. So based on 6, 7, and 8, right, our answers here. What happens to voltage as the resistance decreases or as the resistance increases? So we can see in our problem here, 5 to 10 to 20, the resistance was increasing. Well, what happened to the voltage as the resistance increased? Well, we went 5, 10, 20, 30, 60, 120. They were both increasing. So as resistance increased, voltage increased. They were both increasing. All right, so there's our answer there. The contrast is true as well. As resistance decreases, voltage would decrease, but that's a little bit redundant to write the same thing twice. So as resistance increased, voltage increased. 10, 11, 12, 13. How many we got? 14. All right. So 4 left here, 5 left here. Let's check these out. This time, our question is, what is the resistance? So I'm looking for R now of a circuit with 3. This is a little bit tricky because we have 3 1.5 volt batteries. They're trying to throw us for a little loop, and a current of 5 amps. So 5 amps is pretty easy. That's our current. We'll put the 5A there. We should be comfortable with that. Now, if we have 3 1.5 volt batteries, we actually get 3 times the voltage because we have 3 of the batteries. So 1.5 times 3 is actually 4.5. So that's a little trick right there. Because we're using 3 1.5 volt batteries, we actually end up with a voltage of 4.5. And then we're using our equation that solves for resistance. You guys can flip this over and check. I'm going to bet that I remember the resistance equation is resistance equals voltage divided by current. So voltage is 4.5, current is 5, R is going to equal 4.5 divided by 5. And 4.5 divided by 5 is going to be 0.9. I'm going to guess 0.9. Unit is ohms, which is the upside down horseshoe. And there's our answer. Boom. Continuing. Alarm clock draws a current of 0.7 amps. There's a current when connected to a 120 volt circuit. Calculate the resistance. So calculate its resistance is our question there. So R is our question again. Voltage is 120. Current is 0.7. They're not choosing fun numbers for me. All right, so we're looking for resistance again, so it's the same thing. R equals V divided by I. 120 divided by 0.7. And 120, I'm going to have to do this one in a calculator. I can't do 120 divided by 0.7 in my head. 120 divided by 0.7 is 171.4. Ohms upside down horseshoe. 171. There we go. Moving on. I'm just going to keep using black. This time we have 4 1.5 volt batteries. Question is how much resistance? So we're looking for R again. Current is 0.02 amps. So 4 1.5 volt batteries would give us a voltage of 6 volts because 1.5 plus 1.5 plus 1.5 plus 1.5 is 6. Resistance we don't know. Current is 0.02. And it's the same equation. R equals V divided by I. 6 divided by 0.02. And 6 divided by 0.02 is going to be, let's see, 6 divided by 2 would be 3. Move the decimal point twice. I'm going to guess 300 ohms. Let me just check really quick. It is 300. Good. Resistance is 300 ohms. All right, so there's our resistance questions. No summation for the resistance questions because resistance is what it is. 13 and 14 are kind of mixed problems. So let's see what we get asked here. How much voltage? So I'm looking for V would be necessary to generate 20 amps. This is the first time they're using amps instead of A, but amps is still current in a circuit that has 5.5 ohms of resistance. So they use the word ohms as well. So amps is current. That's 20 A, 5.5 ohms. And we should know voltage is equal to current times resistance. So voltage equals 20 times 5.5. And 20 times 5.5 is going to be 110 volts. Quick math. Last question here before you create your own. Light bulb has a resistance of 8 ohms and a maximum current of 10 amps. How much voltage is the question? Question mark. 8 ohms, 10 amps. And we're looking at our V is equal to I times our equation. 10 times 8, which is 80 volts. There you go. All right, I'll leave it up to you to create your own problem. You can kind of write any problem you want, whether you want to solve for voltage or current or resistance. You just need to give somebody 2 of them. So how much voltage does a car battery have that needs to run 2 amps of current at a resistance of 5 ohms? There you go. There's a problem. Solving for voltage. But you could write one by by anything. And then if you want to have somebody else check yours, see if they can solve it, you can have them solve it. Or if you want to solve it yourself, solve it yourself. Write yourself a problem or write somebody else a problem and then tell me who solved it. It can be you, it can be somebody else, whatever. And the last one here is a little bit of graphing. Geez Louise. So we want to graph voltage and current. You can see voltage is here, current is here. We're just going to graph each of these points on our graph and see what mathematical relationship we see between voltage and current. So Voltage of 0.65, current of 0.12. This is going to be a little bit difficult. I'm going to guess that's like right here. I'm not going to be spot on. I'm just going to try and get close. 1.41 and 0.29. It's like around here. And like around here. 2.55 and 0.51. It's like around here. 3.28 and 0.67. 3.2 and 0.67 is right around here. 4.11 and 0.81. 5, 6, 7, 8, 1. Right around there. And last but not least, 6.15. So that's up here. And 1.23. That's 1.1, 0.2, a little bit more, like right around there. So there's our points, somewhere around there, somewhere close. And if we look at the pattern we see here, we see kind of goes up that way, which means as voltage increases, current increases. We would call this a positive linear hold on, I spelled that wrong. You're not wrong, but I added an extra letter there. Close. Positive linear relationship. Right? It's positive because it's going up this way. It's linear because it looks like a line. So it is a positive linear relationship. All right, so there is Ohm's Law worksheet. All right, you can check out that video, finish that if you need to. I think I'm going to have one more solutions video on here in case you are able to finish both of those, right? Finish taking the notes and finish with all of these practice problems. I have another set of practice problems that you guys could be working on if you need to. So I will upload the video solutions for those if you need the video solutions for those. If you don't, you don't. But you can check that out too. Maybe if you've finished the notes and this worksheet today, I'm okay with that. That's probably pretty good. But if you're looking for something else to do, you can start in on the Ohm's Law worksheet. All right. Ohm's Law practice worksheet is what it says at the top. All right. So I'm going to stop that there and start on that video.